Okay, welcome to this event in our new series here at the Transformative Play Initiative. This time we're going to be talking about game technologies in LARP and tabletop RPGs. Now, the way we are going to set this up is we're going to have about an hour for our presenter to talk about things. Then we're going to have about half an hour after that with Q&A, questions and answers. If you have questions, you put them in the Q&A function, which is at the bottom of the screen. That's the only way we can make 100% sure that your question gets to us so we can ask it to Taisto after the talk is done. We will try to look at chat, but we can't promise. So ask them there, and after the talk, we will ask these questions to our talker. This talk is part of the EDGE project. Now, the EDGE project is an Erasmus Plus funded project, and our consortium works with curriculum development in transformative game design. And the members are Uppsala University, Department of Game Design here on Gotland, Turku University of Applied Sciences Game Lab in Turku, Dragon's Nest in Greece, Chaos Logic in Italy, and Avalon Larp Studio, technically in Norway, but also a little bit spread to different countries. The game technologies in Larp and Tabletop RPGs has the following description. Immerse yourself in the fascinating world of game technologies as they intersect with live action and tabletop role-playing games. While technology has always played a role in enhancing these experiences, the rapid evolution of game technologies opens up a plethora of opportunities to elevate gameplay to new heights. This lecture aims to explore both existing and emerging technologies and how they can be harnessed by users of varying skill levels, from the casual end user to the passionate enthusiast and the professional developer. We will delve into the realm of extended reality, exploring how it can create immersive experiences that blur the line between the physical and digital worlds. We will also discuss game engines, the powerhouses behind our favorite games, and how they can be leveraged to create engaging narratives and interactions. The lecture will also address the potential of artificial intelligence, AI, in gaming, its opportunities for creating dynamic responsive game environments, as well as the challenges and ethical considerations it presents. Lastly, we will touch upon 3D modeling and additive manufacturing and how these can bring our imaginations to life in the form of tangible custom game pieces, costumes, and props. Join us as we embark on this exciting journey to discover how technology can transform the way we play and experience LARP and tabletop RPGs. And here, to talk about this, knowing a lot more about it than I do, is Taisto Suominen. Taisto Suominen is an associate professor at the School of Information and Communications Technology of Turku University of Applied Sciences in Game and Interactive Technologies. He holds a Master of Engineering degree and has worked for over 20 years in the Turku University of Applied Sciences. He's a co-founder of Turku Game Lab and its predecessor Game Tech Arts Lab. He has been active and a key person on the Turku University Applied Sciences game development curriculum design and Turku game scene activities. He was a board member of NeoGames Finland from 2018 to 2021 and continued from 2022 as an observer member on the board. NeoGames is a non-profit association for the game industry to coordinate and support the growth and development of the Finnish game industry. His research interests include utilization of game and interactive technologies on various domains, serious and entertainment games, extended reality, game graphics, and content creation. Now, what that impressive bio does not say is that Taisto brings to any interaction you will have with him a playful, joyful energy that is impossible to not love. And so I got to meet Taisto first, of course, through this project that we're both on. But I felt that very quickly it was easy to call him not only a collaborator, but also a friend. And I hope the feeling is mutual. Taisto, please take us away.
All right. Thank you, Chell. Okay, so what Chell didn't mention was my hobbies. So I'm a sort of this 21st century digital boy. So I love technology. That's why I'm probably at this profession. And it of course include gaming, but also I have a hobby of 3D printing, laser engraving, and fishing is my passion. And for that, I actually love to create my own lures, and I use the technology that I have in my hands, all the 3D modeling, 3D design, 3D printing, but also traditional metalworking and then painting by hand. So here are a few examples of my experiments, and even I got a fish with those, so obviously it worked. But let's dive into the topic. So first I will introduce a little bit of what kind of tech there is available, and then I will take a few of those technologies in more in details. So of course, in LARP, and as a LARPer, I'm not actually a LARPer. I've participated now a few times with the help of Chell and Sarah to LARPing, but prior to that, I had no experience on LARPing. So you are the experts probably there. But from my point of view, I approached the available technologies and what could be used in LARP. So of course, mobile applications. There's a huge amount of mobile applications available that we could utilize. Those, of course, include all kind of communication technologies, but also content creation with mobile phone, scanning with mobile phone for 3D scanning. And from that, we go to 3D modeling and photogrammetry. What we could utilize for creating, for example, backgrounds, virtual backgrounds, and use them this kind of same way as, for example, movie industry uses this kind of either projection walls or LED screens that we can utilize for that purpose. 3D character development, that's something because I've been 3D modeling from 90s. So I instantly thought that of course 3D character development is interesting topic. There are lots of tools, browser-based, that you can modify characters, create from images. Like if you have a portrait of yourself or someone else, you could create simple character from that, and more pictures you have, the better result you get. And then there are this kind of slider based that you can use sliders to adjust the proportions of your character and all kind of that. And that comes also to virtual clone. So I will showcase a virtual clone of myself in a game world. So that's definitely interesting. And from that, we can jump to extended reality. I will explain more detail what is actually extended reality, but practically it contains all kind of reality technologies. And for that, VR chat is a good example of existing technology that can be used, and it is used in LARPing. Of course, lighting, stage lights, those are already been used. Communication technology, so traditional phones or voice chats or then text chats like Discord and WhatsApp. Then of course NFC and RFID, so we could have tags that we could read with our mobile phones, and we could launch different actions based on that. Then GPS and real-time location tracking could be utilized either by knowing where we are or where the players are, or then we could launch actions based when the player gets to a certain position in the real world. Audio technology, of course, audio is part of the immersion. Generative AI is kind of hot topic currently, at least in our engineering field. It has potential, it has risks. 3D printing, as I said, it's a passion and hobby of mine, and it provides huge opportunities for costumes, realistic costumes, and equipment. And for that, we could use microcontrollers to put enhancement, kind of LED lights or voice or sound effects. Online communication sort of relates to that communication technology. And then motion tracking for live animation. That I had in mind for that we could have actually live acting, and then the characters, what spectators see, are actually 3D models that are tracked from the live animation. So basically live puppet theater, basically. Future tech, so what is happening? What are all the new technology that will arise? There are some hints on that. Maybe during this talk, we can see part of that. Then when you come to tabletop RPGs, that is actually quite interesting, and there's already a huge amount of software available, which I will present in the next slide. But if you think about how could we use technology, so we could have virtual tabletop platforms. We can use applications for world building, both in 2D or 3D worlds. Applications for character development. So not only the physical appearance, but the other aspects as well. Audio technology for tabletops. So how cool would it be when we can actually have audio effects when the player enters on a certain area, or based on the mood is what is happening in the game. Then online communication, again, we could play the same board game in different locations utilizing communication. We can print our characters and environment ourselves. We can use generative AI, again, for the content creation, maybe write our own stories, enhance our own stories. So usually, as for example, if I'm this kind of writing a story for my video game, for example, I have some kind of idea, but I need to enrich that somehow. And there is kind of potential for generative AI that it can add to my story. It can build worlds from my story. It can create characters from my story, and also graphical content. Then AR features and mixed reality features. In the images you can see on the left, there is actually screen capture from my students whose task was to make AR enhanced board game. And that's something that there are already examples from commercial games that has AR features, but still it's quite limited amount of that, and there's huge potential on the AR features. And then again, those NFC RFID readers. So basically we can use our phone to read some tags, and then based on those, we could launch actions. As I mentioned, there are already huge amount of tabletop applications. And here are a few examples. So Roll20 is a real-time game board. There is character generation. Dungeon Alchemist, it's an amazing 3D application that lets you create your worlds, which you can then print as a 2D. They have upcoming features that you could actually have the 3D version of that as well. But currently it supports only that you can print 2D version of your 3D world. Fantasy Grounds has rules for many RPGs. World Anvil is a world building application, and so on. There are quite many different ones. Hero Forge is interesting, actually, that you can create characters and then you can order them as a printed models. And then, of course, if you are enthusiast, You can 3D model yourself using open source software like Blender, and then print those game objects, and also utilize game engines on that. And here's another example of my student-made AR board game application on the game called Bang. Let's first jump into the world of the XR, so extended reality. And this image is actually from our lab. It showcases this forklift simulator, which was done in our Tuas social platform. It's sort of multi-user VR environment. So you can have multiple VR users in the same world, and also desktop users. What is XR, extended reality? So extended reality is basically an umbrella term that has all the other R's inside. So we have mixed reality, which is basically in the middle, and that's kind of the newest technology in there. And then we have a little bit older traditional technologies, virtual reality and augmented reality. And mixed reality basically combines those two. So we have both virtual and augmented reality features inside mixed reality. Mixed reality is kind of that last year, 2023, Quest 3 by Meta was kind of the first consumer price category device that can handle mixed reality with enough quality. And that's kind of the undiscovered country currently. There is huge potential in mixed reality. And there's nice examples of, for example, mixed reality chess, where you can play chess with your friend in the other side of the world. You're using your real chessboard and your own pawns, and then you can see the other player's pawn on the mixed reality version. For mixed reality, we are using head-mounted displays, HMDs, and there's currently Microsoft HoloLens, Magic Leap, Vario, and MetaQuest, and of course the newest one, Apple Vision Pro, which is not available in Europe yet. Those are currently these mixed reality classes. On the virtual reality, there are lots more availability for the classes, head-mounted displays, and motion controllers. And there's Valve, HTC, HP, Vario, and Meta, which are the brands on there. Augmented reality is basically that we use device, and using that device as a see-through, we can see some additional content, digital content in our world. And that could be there are AR classes and mobile devices. Mobile devices basically means that you can use your own mobile phone and utilize that as an AR device. How can we then utilize XR in LARP or tabletop? The simplest solution is use existing XR games and applications. One of which is basically VRChat, as I mentioned before. So it's a free application and it's already been used. The pros in that, it's easy to use, and there's lots of already made content. There are ready avatars. You can create custom avatars really easy. There are lots of environments, and lots means like hundreds, maybe thousands of environments to choose. There are already interactions you can do, drawing boards, drawing items. There's voice chat integrated, and you can have a public or private sessions. Then the other options are to use XR applications that are made for content creations. So there are these kind of applications that basically are like a MS Paint or Photoshops inside VR, that you can create 3D content, have actions, and utilize those. There are also some of those are multiplayer, so you can have multiple users utilizing the same time those. And then the third option is that we actually need to use game engine to either create a custom application from scratch, or then utilizing or creating a world, for example, in VR chat. So in VR chat, it's possible to use Unity game engine to create custom environments. You can create your own avatars, you can 3D model themselves, and then you can create custom interactions. But that kind of requires the knowledge of the game engine, and it's not an easy task, but it's possible. And here is actually an example of one of my students who made a classroom here at our campus as a VR chat room. And here is an example video of our RDI projects that showcase kind of possibilities of multi-user VR environments. Okay, let's jump into the AR, augmented reality then. So as said, we are augmenting our biological world with digital elements, and use cases could be advertisement information, interactivity, training, edutainment, or board and card game enhancement. We're trying to kind of create this wow effect. And now what happened actually that is AR was really, really popular, at least here in Finland. Like, it was a rising technology. There were a lot of companies creating AR solutions in 2015, 2016. And a few years after that, it kind of went gone. So now it's more of a novelty. There are still some solutions for AR, but it's more this kind of gimmick. And here in the picture, you can see our this kind of application where we try to enhance a board game. We have a deck of cards, and each of the cards is readable with your phone, and it unlocks, it shows a certain like additional 3D content and unlocks features in the game application. And we made this actually 2015 with my students, and we printed all the cards, and then kind of tested this kind of it was this kind of exhibition game in a fair event. And the idea was that people will travel different stands. There were 7 different stands, and then you get reward cards, which you can read with your phone device. But we made a major design flaw that we put a QR code behind the card, and people were using this QR code and complaining that it doesn't work because they didn't realize that this is the marker. The QR code itself took the user to the application download site, but because he had already the cards, he would have the application, and small design error. But kind of that's one way that if we have physical cards, we could basically utilize those and ask our application to provide some kind of additional content that is our design choice. Easiest AR applications are Aira. It's an Adobe Aira, sort of a mobile application where you can just design and decide what you want to happen in different markers. And then there are applications like Avalon, which is a web-based application, and you can build your AR application. Or if we want to make custom, we need to use, again, Unity or Unreal game engines. And it again requires somewhat knowledge of the engine itself. How the augmented reality works is that we need to decide that are we tracking images. So the image needs to be good contrast, and then we can track it. We can detect planes, 3D objects, so kind of physical objects, or faces, for example, this kind of face swap applications and kind of what Facebook and other medias are using, that you can switch different items, bunny ears and whatnot, to your face. Those are using AR. Then, of course, we can use LiDAR or depth camera to enhance the accuracy. And for example, Apple devices are using those, and that's why they are more accurate, as an example. Then on this image, we made a fire safety game to elementary school children. And the idea is that we actually read the safety signs. And then other example is our cultural heritage application, which was awarded Best Applied Games in Finland 2018. And there is 4 locations in Finland for this kind of old castle ruins. There are this comic strip in the world, and you can read them with your mobile phone and have this kind of 3D characters that are from that cultural era. And here's another example project. So it's a Turku Castle AR app where you can visit Turku Castle and learn from the paintings more details. So kind of otherwise you would need to have a guide or a guidebook, but you could have your application, and when you just read the photo, you learn something new. Then I mentioned already about game engines. So game engine, nowadays, people are calling game engines as content creation engines because they are used beyond games. Traditionally, they were made first for games. And there is actually 3 kind of top engines currently. So there's an open source engine, Godot engine, and then there are 2 commercial engines, Unity and Unreal Engine. Unreal Engine has currently 2 versions that are used. The 5th version came last year, but people are still developing with the previous version. Idea behind the game engine is that we can start development right away, and it has a bunch of features that we can use. There are also, because game industry has been around rather a long time already, there are many of the older and bigger studios, they have their own engine development. And some of them might actually license that to other developers. And here are a few examples like Remedy, Rockstar has their own engines, DICE is creating Frostbite engine, Ubisoft have Anvil Next engine, Valve has Source engine, and then there is a Cry engine, and Amazon fork of that is what is called Open 3D engine, previously known as Lumberyard. But that's not very famous in Europe. It's more used in the United States because it's so heavily intact with the Amazon services and web store. Unity game engine is sort of one of the easiest game engine to approach. It has huge amount of features, and it has a low learning curve. Here's an example image what the Unity game engine looks like. So it's basically, if you have any experience on 3D modeling software or 3D softwares, it's rather looks exactly like those. It might have more windows, but we have basically the 3D view, and then we have a bunch of other windows that we can inspect and handle our project. Unity, as said, is kind of really easy content creation, and we can do multi-platform development. That means that we can have, for example, PC development, we can have mobile development, smart TV, or mobile phones and whatnot. And that's basically only one of the biggest reasons that why would you use game engines, that you can right away port your application to different platforms. It also, Unity allows you to learn about game development and add steps to your development process. So it has lots of features that you don't necessarily need to use right away, but step by step. Unity supports both 2D and 3D development, and it's also super fast for prototyping. It's designer friendly, and it also has this kind of visual scripting that if you know programming logic, it's rather easy to visually script that. One of the best things in Unity, it has huge amount of third-party tools and assets. It includes APIs like Google Maps or Bluetooth services and all kind of that. It has a huge community that is helping each other, and it's really popular. Of course, Unity had some hiccup last autumn when they changed their terms of services and a little bit license, and it kind of drove people a little bit towards other engines. Unity is available as a free for students, academic institutions, and for personal use. And again, one best feature is that it runs rather low spec. So if you have not the most powerful laptop, you can still run Unity with that and develop games. So that's kind of why it's such a useful tool, for example, in our student projects, that it doesn't need so much from the workstation. Unreal, on the other hand, is sort of aiming for the visual fidelity, and but it kind of looks like the same as Unity. And if you have experience from the other engine, the approaching the other one is rather easy. They are using a little bit different naming convention, but other than that, the logic behind game development is similar in both engines. So Unreal Engine, its out of the box visual quality is stellar, and it has really nice lighting engine. So same project, if a newbie game developer starts, usually Unreal Engine projects looks better because the native visual quality with the lighting is better. If you compare like which engine makes better looking graphics, if you know your way in Unity, you can make exactly as good visual quality in Unity but it requires a little bit more knowledge. Unreal Engine has lots of inside engine tools, including physics destructible meshes and cinematic tools to create different kind of cinematic videos. And it's used a lot in the visual video productions. Again, it's freely available, so you can start learning free. There's a really huge amount of online material available for free. And it's really artist and designer friendly as well. It has also the blueprint system is visual scripting system, and all the tools that artists can utilize are basically easy without code base. And especially if you have experience from Unity, it's really easy to shift. And one of the best features in Unreal is that it has huge amount high quality free content. So there is this Pixel Megascan ecosystem that holds a ton of free assets that are photographic quality. There are AAA content from previous games, and they provide monthly free assets. And also Unreal is free for students and personal use. Then we could jump to AI. And I actually discussed with Microsoft Copilot, which is an AI tool provided by Microsoft. And I asked, could you explain simply what is AI? So this is the explanation that it gave us, that AI is not just the technology, it's also understanding about human cognition and relationship with machines. And it's a tool that amplifies human potential. So that's kind of how I see AI. It's a tool that amplifies my potential, and that's how I'm using it. And here's another slide showcase generated by Microsoft Copilot. So how can we use AI in game development? So generative AI is basically a tool that lets us create different content. It can be text content or it can be picture content. But also it can help us code. So we can create our own programming code. And here's an example of AI used to create, for example, game background. So this is done with Midjourney, generative AI. So we give a prompt, what we want to have, and then the AI produces us few pictures based on that. And with this prompt, we got this picture. And then I used another AI tool inside Adobe Photoshop, generative fill, just to extend the previous picture, and it created me this huge, beautiful background image that has the tree that was previously generated, and then it continued the same kind of scenery. And here's an example of a workflow. How could we utilize AI as a helping tool? So everyone can draw this kind of sketch, basically using Microsoft Paint kind of tool. It's now done in Photoshop. So we kind of paint our first sketch. That's something we want to have. And then we feed that as a seed image to AI. And we start to add details via text prompt. And then when it gives us multiple pictures, we can take from each of these pictures that, hey, that part is good. The other picture had that X blade was good, and we can combine and mask those inside Photoshop until we get the final result, which we can then upscale utilizing the AI to larger image. And basically we have a game-ready asset. And here's another example of a different image. And this workflow was introduced by Albert Bozan and he's a YouTuber, and he has really interesting channels. So if you're interested to learn more, you can follow from that. For content creation, there are lots of tools. For example, 2D graphics. We have those traditional Midjourney, DALL-E, MS Copilot is actually using DALL-E, Stable Diffusion, which is an open source, and then we have Adobe Photoshop, Illustrator, which are using the Adobe Firefly engine behind. For 3D graphics, it's a raising new feature that we can actually create a 3D object based on our text prompts. And there are a few ones like Meshi and Luma Labs. And then you can utilize Blender 3D modeling software with different AI plugins. For story, character, and world building, we can of course use ChatGPT or the MS Copilot to give a seed story or setting and start building on that. Pseudowrite is another tool that actually, when you give a seed story, you can start adding details, asking it to generate world based on those and character based on that story. Dungeon Alchemist, as mentioned before, is a 3D AI world building. And then, for example, Chat Avatar is a new contender here. So if you have a few pictures of yourself, you can create, for example, 3D model out of yourself to be used in your game. It's sort of easy to approach 3D content creation or digital twinning, virtual cloning. Audio is, of course, a rising topic on the AI utilization. There are lots of web apps, so web-based applications that you can create music, sound effects, clone your voice. And then there are tools for digital audio workstations, also known as DAWs. There are tools for composing, creating lyrics, and other similar. And there is actually one of my favorite YouTubers, Dr. Mix, has an interesting video about that. So that's something, if you're interested on how can AI create lyrics, I'm recommending the watch Dr. Mix video. It's kind of mind-blowing what these tools can do these days. Then AI voice acting is lots used in video games and also actually in the Hollywood productions. So for example, the Obi-Wan Star Wars series, Darth Vader was acted by AI that was cloned, that was using the clone voice of James Earl Jones. So it's actually one way that we can clone the voices or just create a new voices, the voice acting. Interactive NPCs, that's definitely something that we see in the futures, that we can have a endless game loop, that we can interact with new NPCs that have different story. And NVIDIA has this ACE technology, and they are utilizing this Convo AI tool as well there. Natural language interaction. So basically that we can speak and the game understands and reacts to that. Then I mentioned already about voice cloning. Meta has their own voice box that you give 15 seconds of your voice and it can clone from that. Programming, so we can create the programming code using ChatGPT. And then game engines has these days, of course, their own AI tools. So Unity has launched their Muse tool that you can create either programming code or graphical content or even animations. So you have a 3D character and you can explain that I want to like walking animation. You can create, give details how it works. Maybe he's drunk and he's working a little bit awkwardly, and you can tell that to the AI, and it will make that animation based on that sort of procedural AI animation. Few examples. Unreal Engine has their own neural network engine that can integrate different kind of similar features as I mentioned before. Unity Muse has, so animation, audio, programming codes. And here's an example of the capabilities of those current 3D models made with Luma Labs, for example. My colleague Yami Aho made this. So only prompt that he gave us, medieval armored goblin, and this is what we got. And it's actually 3D model, so you can download it from here, and then you could 3D print it, for example. It's not perfect, but it's actually rather good if we think about like how fast this process has evolved. Here's an example of Conf AI NPC. So they have a back service window. So this kind of website where you go and fill in details about the characters. So this is now my character. It has my avatar inside. I created the background story. I actually put my bio, but I changed my name to my old gaming nick, Jimmy Outstanding, and wrote a little bit background story. You can also create different kind of personality state and state of mind, and this kind of additional details there. And then here's an example of I used ChatGPT to program me a Bong game. So here's an example how it went. So the winning player was the CPU. It was too good for me. So that was just an example that what you can actually, how you can utilize that. Okay, I'm not a programmer, I'm actually a technical artist myself. So I can do 3D modeling. I understand about scripting, but I cannot program. So I asked ChatGPT to create me for each the ball, the battle, and the CPU player, the program code, and it actually went rather well. So this took probably 1 hour, and it was my first test. So here's an example now, me as a virtual clone. It has my likeness, and then it's an NPC that talks to me.
Greetings, fellow. How are you, Jimmy? As an enthusiastic and knowledgeable guide in the realm of game and interactive technologies, I am here to provide you with insights, advice, and assistance on your quest for knowledge and exploration. Together, we can unlock the secrets of this exciting world. Could you tell me a joke? Why did the programmer go broke? Because he lost his domain in a virtual reality auction. What is your favorite catchphrase? Oh, I have so many favorite catchphrases in my arsenal of geeky expressions. But if I had to choose one, it would be, when you got the tools, you got the talent. It perfectly captures the essence of being equipped with the right skills and knowledge to accomplish great things in the world of game and interactive technologies. Thank you, Jimmy. You're welcome, fellow adventurer. If you have any more questions or need further assistance, feel free to ask. Together,
He was a little bit geeky, but other than that, quite nice guy. Okay, so then what is actually the ethical parts of generative AI? So one thing is, of course, that when we are creating the AI, we need huge amount of data. And with data, there's always privacy and security. And then another thing related to the data is copyright and data ownership. So how the data is collected. And that's actually the major issue that has been when the AI tools gain popularity, that we realized that the data sets that the AIs were used to train with, they weren't necessarily copyrighted, that they can use that. And that's kind of the one issue, that they kind of stole the data, they didn't ask permission, and now we are in the situation that it's affecting too many content creators and creative creators. So basically, transparency on that, how the data is collected, is important. Then, of course, that all the models should be trained with a way that minimize the bias. Then, when we are kind of training and using the AI, it's consuming huge amount of energy, electricity. The AI can distribute harmful content, and that kind of means that we need to have the human in the loop to ensure the ethical use and supervise the AI actions. And then it of course needs that the AI models needs to be tested, refined based on the testing and feedback. Then about 3D graphics and 3D modeling. The 3D graphics actually, because of the evolvement of the game engines, we are now in the situation that the 3D graphics are near photorealistic, and the gameplays are really visual and enhancing. You have probably seen some videos made with Unreal. If not, YouTube is full of these fan films made for different topics that are amazing, and they are all done in digital content, and it's really hard to distinguish from is it a 3D or is it a real one? And that's kind of, we are on the edge of, it's hard to tell when it's real or when it's 3D. And it's real time. So real time 3D graphics means that it's rendered in your computer while you're watching it. So it's not a video anymore, because in movie industry there has been already the visual effects are in the state that they pre-render it, and it's hard to tell which is real and which is not. But now when the games are that it's actually happening where we go, and that's kind of what is interesting on there. 3D modeling, basically, that we create the mathematical representation of the three-dimensional object, and we do it with software like Blender, Maya, 3ds Max, and sometimes we can use the help of that generative AI. There are a few different workflows inside 3D modeling. So there's this traditional polygon model. Polygon is basically the building block of a 3D model. So all the 3D models are made of polygons. Polygon then consists from edges and vertices. So one vertex is 1 point on that 3D model. And when those points are connected, there is an edge between, and when we have 3 or more vertices, we have a polygon. Then we have spline modeling. We can do sculpting. We can do kit bashing. Kit bashing is basically means that we combine different models, and it comes from the old this kind of model workflow from when kit models were done, so that if there weren't like certain kit available, you took several like car kits and glue them together and you have a new car. That's basically kit bashing. Procedural modeling is basically mathematical modeling that we have different kind of presets, maybe pre-models or just mathematical equations. And then we combine those and it creates us the model. One of the new uses are photogrammetry. It's not new technology, but it's not now in the past few years, it has been used more and more in games to create 3D models. With the help of AI, we can actually use this NERF, which is neural radiance field. And Gaussian splatting is another technology that it's basically photogrammetry that utilizes limited data set. So photogrammetry usually needs that you have hundreds of photos. NERF and Gaussian splatting requires only few photos. That's kind of the difference between those technologies. Then the resulting model, we export that to game engine, but quite often it kind of requires more work. And here is actually a process of that work, how it's actually done. So we start with concepting, and then we take references. For example, if we have this kind of wooden barrel, we use Google's image search, wooden barrel, and we get tons of wooden barrel, and we try to take what could fit our team, and then we create a blockout model, and then the actual process starts. So how it's done that we create first this kind of high poly. So what it means that we have high polygon amount model that wouldn't run in game engine. So it's this one over here. So this one has really huge amount. It has millions of polygons. And then we create low poly model, which is basically the game ready model. We need UV map. UV map is basically a 2D paper cut of that 3D model. So if we would made it from paper, what kind of parts would we need? It comes from that in the 3D modeling, we have X, Y, and Z axes, and textures are using U, V, and Ws. That's the coordinate axis for the textures. That's why it's called UV map. Then these two models are combined so that we take the low poly model and we bake the high poly data into that low poly model. So it creates this kind of mesh maps that we can utilize to tell that it has certain, like this barrel example, it has the metal bands and it has the wooden boards, and we can see them now in the baked data, but they are not actually there. They are just texture data that the game engine understands. We have the texture data here, and then we have the actual game ready model that looks like this high poly model, but it's actually this low poly model. So that's kind of the basic story, how it's done. And basically we do use modeling like Blender, and there is texturing software like Adobe Substance Painter, which then can do the so-called baking of the low poly to high poly to low poly, and then we can do the texturing for the metal parts. And then my high poly here has blue color for wood parts and red color for metal parts, and then I can tell inside my Substance Painter that which parts it's like this kind of color ID map which I can pick that red is metal and it will mask out the other one. This is kind of simplified version of the workflow. Now the photogrammetry is kind of astonishing technology that we can create 3D model of the real world items. It can be huge like this church, or it can be something really smaller one. On the workflow wise, it's a little bit similar as the previous, but it's basically contains that we photo the target. And as I said, when we are using photogrammetry, we need multiple photos, hundreds of photos. Then we take those photos to photogrammetry software, which calculates this kind of dense high poly model. And to get that to game engine, we need to sort of create this retopologized low poly model. So the retopology can be done by hand. So you use it like Blender and you draw where you want your polygons to be. Or then there are automated tools that they take this kind of good geometry sample and they wrap the geometry to the photo scan. And this is, for example, photo scan of me. You can see that there's lots of data here. And then this is the wrapped model, and this is now the rendered version of that. So it looks like photograph, but it's actually a 3D model, and it can run in game engine. If you are interested to see more of these features, my friend Lassi Kaukonen is a small entrepreneur that does content with photogrammetry, and he has really nice sketchwrap portfolio. So following that link will take you there. And then kind of last part in our presentation is additive manufacturing, so commonly known as 3D printing. For personal use, we have basically two different technologies. We have liquid photopolymer resin, or then we can use this fused deposition modeling. So we have liquid plastic, or then this solid plastic that we melt to create our models. This image now, this is a Mortal Kombat Sub-Zero mask I used on our Halloween party. And here is, of course, the famous Stormtrooper helmet. These both were done with this FDM printing, so melting the plastic and doing it that way. And they are rather inexpensive, these 3D printers nowadays. And there are lots of different manufacturers providing their own solution for 3D printing. There are a huge amount of communities that share their knowledge and printable objects for various categories like cosplay and movie props, board game elements and board game characters, and so on. How it's actually happening that we can download free models. There are services like Thingiverse and Printables. You can purchase 3D models for different sites. Usually the paid versions are better quality. And you can even order from a 3D artist, I want this model, and they can make you that. And then there are sites like Hero Forge that you can actually have custom miniatures and purchase from there and print yourself. And then you can 3D model yourself. So basically, we can use Blender to 3D model, or then use this kind of 3D CAD, which is more purposeful for that actual, like we can measure accurate measures for our models. Then we use 3D CAD softwares like FreeCAD or Fusion 360 are these ones that are available and easy to approach for consumers. Then, of course, one option is use 3D printing service. So, for example, local industry, there are lots of entrepreneurs, for example, here in Turku that I can order a 3D print. And then there are these post-service models like Hero Forge that you can order it via mail. This example is a model that I printed from a local game studio. It's called My Tale. They have a new upcoming game in Steam, and they had their game character, and they asked, could I print it? And I printed it with my low-cost printer. So this printer was only 99 euros in Black Friday a couple of years ago. The resin costs about 40 euros per kilogram, and sometimes you get half price sale offers. So about 20 to 40 euros per kilogram. And then you can print quite accurate 3D prints with only €100 device. And how it's the process goes that you take the 3D model from the 3D modeling software, and it's put on this so-called 3D slicing software. It kind of means that the slicer creates layers, because the printer works that it prints one layer at a time, and the resin printer has a more accurate layer, like the layer lines are thinner, and that's why you cannot see the layer lines, but with the FDM printing, you actually can see the layer lines. That's why it's called slicer, because it slices the print and it transfers that so-called G code. It's a code that the 3D printer understands. And then we can just press export from here, put it to our printer and press print, and it appears as a solid models. If you can see my camera, there's the solid model of the 3D print. Here's another one. And then, because it's not really large, my printer, here's an example. If you want larger model, you can then just print it from separate parts and combine them together, and you have a Luke's laser lightsaber. All right. So now we are at our conclusion slide, and kind of hint of warning here. When we are using technology in LARPing or role-playing games in tabletop, there is always the unpredictability. Things can go wrong, and usually they will go wrong. There are different dependencies like electricity. Some, for example, using VR classes, they need certain amount of ambient light. They have small batteries that you can use only like maybe 1 or 2 hour gameplay time. The battery can drain instantly. They might need internet connection. And there is always this kind of setup and upkeep. However, the technology can be the immersion that we need. One kind of clue is that if we use well-known technology, sort of the old technology, there's the reliability and assurance. For example, if you have familiar devices like your personal mobile phone is the device you use in your gaming, it helps. You know your phone, how it works. You know when your battery is dead. And you know the problems. And then we don't need orientation time or training. If you use new technology to the people that has like never used VR, for example, there is some time to get oriented, onboarding and training that it's required. We can, of course, limit the features that maybe take away the controllers. You can only use the head-mounted display. Because if you give a button to LARPer, he will push it and maybe break things. It's really important to test. And it doesn't matter how many times you test, it can still go wrong. So test, and test again. And always have the backup. What if this goes wrong? Then it's of course really important that you have a discussion that if there is a technical difficulties, technical issues, how can we handle that without disrupting the immersion or the magic circle? So those are kind of my key points. If you are interested about all kind of this goofy and geeky but interesting stuff, here are some additional reading links. History of VR is interesting. Adobe AR is kind of, if you are interested about AR, you want to try with low limit of knowledge. Adobe AR is like using PowerPoint, but you can create AR applications. Immerse, it's a huge, I can see this, how I would play chess in the future. There are a huge amount of game engines. There's a list for that. I talk about the nerfs. What is that actually, and what is the practical use case for nerfing? 3D Gaussian splatting is the next technology. It will be huge because we need the limited set of data to create the photogrammetry. Futuretools.io is a site that is kept by Matt Wolf. It's a YouTuber who creates this kind of AI tool content, and he has a huge list of AI tools for different purposes. Then, for example, in my video, there was talk about, or there was an image that said neural network. What is that? That's a good knowledge. If someone is talking AI talk, you can participate when you have read the neural network article. Best 3D printer, it's a matter of opinion, but there are a listing of that. And then if you are interested on 3D printing your own tabletop game, there's a nice article about that, what kind of process it is.
Thank you so much, Taisto. There are quite a few questions that have come in. I will try to, some of them are quite similar. I'll try to bring them together, and so we can have one question at a time. But also, I just wanted to say, for those wondering, we will try to make all the links and everything in this presentation available when we, in our social medias after the talk. That would either be on YouTube or in our Facebook mostly. So don't be afraid if there's stuff here on the slides that you really, really wanted to dive deeper into. We will make that available. Just follow us in social media. We can start with one of the first questions you got, because you immediately said that you are new to LARP. What have you learned so far about the integration of LARP and technologies in this project?
Well, I learned that they can go wrong. That was the first kind of, I was quite certain that tech wouldn't go wrong, but we had in our LARP session, in our kind of initial testing, everything went well, everything was working, but in the actual LARP session, the simplest technology of using Zoom phone call didn't work. And I was kind of not expecting that. So kind of the thing combining tech with LARP, I learned that expect the worst to happen, or this kind of don't trust the tech. Although I'm a tech guy, maybe that's why it's hilarious that that's the one thing and that you integrate and it can go wrong. So many ways.
For context, for the viewers here, we ran a LARP before Solmukohta this year called Meet Me Halfway, and it was a real stress test. But we also, I feel we put the list fairly high to give ourselves a challenge to run a lot of things at the same time. But yeah, never give a LARPer a button, because they will push it.
That was the one. Don't give a button, because it will be pushed. And then even the simplest technology can break, basically.
Because that was interesting. The phone call, of course, being the simple technology, while the full VR being the more advanced one, and the full VR we really didn't have any technical issue with at all. So that was interesting takeaway. We're going to move a little bit into AI, because of course that is a subject that is on people's minds, and also quite new and maybe a little bit scary as well. And can you tell us what examples of AR are most ethical to use in terms of not taking art from artists without their consent?
So basically, Adobe is, if you want to use ready-made solution, Adobe Firefly is using only Adobe stock data sets, and they haven't trained their model with anything else. Of course, that's another topic that did those who contributed to Adobe stock, like 20 years ago. They really understand how the other people use them. There is a disclaimer probably that they can use how they see those Adobe stock photos. But basically, Adobe stock is, or the Adobe Firefly is the most ethical AI I know of. The other option is that we can train our own AI model utilizing dataset that we collect. It can be your own previous work, or if you have a company that has a huge amount of previous content, we can use that to train our own model.
Yeah, because in regards to large language models, wouldn't you need a very, very large data set in order to for it to have the quality that you see
Yeah.
in these maybe less ethical available engines?
But there are also data sets that are made available that are ethically correct. So those can be also used.
That's good. That kind of
But
leads
it's
into
problematic.
yes, so that kind of leads into the next question because, of course, it's a question of quality and I think you also had it in your in the beginning what AI was. It's about trying to replicate and imitate human behavior. Um, what areas of technology are still not quite as advanced as human creativity and interactions? Like where's AI lagging behind the most?
Well, basically that, for example, if I take example of like game assets, so the quality that human can create is superior, and like this kind of certain kind of personality, I think it's only a matter of time when the quality and the personality, the variations can be there. But I think that's kind of that. If you are really making certain style of content,
Yeah, that kind of leads us into a because when we're talking about ethical considerations, there was a question here getting on virtual tabletop platforms. There has been some debate on different ones due to social policies. And regarding social policies, the question, the one asking the question is referring to for instance, the tabletop simulator reported censoring of LGBT identity, though it's certainly not the only example. Do you personally have a particular preference for one of these virtual tabletop platforms, and if so, why?
no, I'm not. I haven't played tabletop RPGs for maybe 20 years, so I haven't tested those.
Yeah. But of course, it's an interesting question because we talk a lot about ethics and AI, and there are very open, glaring questions that we need to handle. But any sort of tool, any sort of technology you use, there might be ethical considerations with not necessarily the technology itself, but how the companies that provide it act, right? So of course it's complicated.
It is.
Absolutely. Let's see. We had a very interesting question about AI that I wanted to ask you here as a follow-up. Um, what would it take to be able to use AI to play test games? Is this viable yet? Would it work at scale for a LARP perhaps with 30, 50, 100 players?
Well, first I have to say that I'm not I'm an AI user, but I'm not an AI expert. But I would say that there is already people, some companies are already using AI as testing.
And by that you mean because what I'm seeing is maybe are they using AI instead of playtesters? So like the active player is an AI that interacts with an AI created environment, or
That I don't know.
no? It's a very interesting question though, like because the potential as we all know that the potential, of course, is probably significant. But the question is when and how do we get there? Which sort of leads me to the next question here. In your presentation, we see that analog games are going more digital, and digital games are entering the physical world. Is there a sweet spot in future games where these two will meet? How do you see this future of games?
Well, definitely, as we kind of discussed already, I think in when I visited in Visby, that we can have the analog board. That's kind of where I see it, that we have the physical game, but then we can have the digital content and reactions and changing stuff. Like it can be like action inside those physical games. It can be just moving platforms, but it can be also like maybe something digital inside the board itself. Maybe something like that.
So maybe a future where it's almost seamless, where there are just different varieties of games, and of course for a game scholar that is a thought, because there's always been this great divide between digital and analog games, at least in the academic fields. So it's really interesting. I have one final question here, and it's more of a philosophical one, I think, and I'm not going to guess who it came from, but it's probably somebody who's an analog player of tabletop and LARP. What happens with our imagination when we can see everything on the board?
Yeah, that's true.
Yeah.
Because also kind of that for humans, limits creates the creativity. And if there is no limits, are there creativity?
That is a very, very good question, and a really nice place to end, I think. So thank you so much, Taisto, for this wonderful talk. This has been Game Technologies in LARP and Tabletop RPGs. It's presented as part of the EDGE Consortium. It's an Erasmus Plus project that is aimed at developing curriculum in transformative game design. The partners are Uppsala University, Turku University of Applied Sciences Game Lab, Dragon's Nest, Chaos League, and Avalon LARP Studio. For those who liked this talk, it will be available on YouTube. On YouTube, if you like this, you will probably find other things that you like at our Transformative Play Initiative channel. So go there and like and subscribe. If you are on YouTube, just click next somewhere here and go to our next video. I'm sure it will be interesting to you as well. Our next event is called the TAG Spring Game Jam 2024, and will be on Thursday, May 16th at 7 o'clock Central European Time. Now, you might ask yourself, what is TAG? TAG is funded by Circus at Uppsala University. This event is part of our new research network called Transforming Games, Behavior, Identity, Culture, and Community, joining researchers in game design, gender studies, and psychology. And this particular game jam will brainstorm concepts for children and teenagers, focusing on themes of emotions, society, and well-being. So follow us on Facebook. You will be noted when this next event is coming up. And thank you very much for watching.